used Nearpod. It has the same ability, I guess. I haven't used it yet because I already have my PowerPoints made and I don't necessarily want to have to do them all over. Let's see, there we go. Good morning. I'm hot. Already hot. I just got here. Oops. I got awful static in my shirt. See when that happens. Okay, everybody looks good. Yep. Good morning, everyone. How's it going? We have successfully passed hump day. All right, I'm going to go ahead and share my screen. We're going to Canvas. You can either go to current lessons into the day we are on, or you can go ahead and go to your calendar where I've given you an agenda. I don't know if that's helping or not, but hopefully it is. So if we go to the calendar, you're going to see that you have some dates popping up. Some of these things have already happened. So you have your DNA web quest, which will stay open for you to submit late till Friday. You have the 3 things article that you were reading about twins. Interesting thing is, somebody asked about twins. They said, well, would that work for triplets? Well, it does. However, to be identical. However, as you go up in how many number of children you have, it gets less and less likely. There are a few things due on Friday. You'll see that when we get into our agenda. Let's take a look at today's agenda. You'll see here, right here are the due dates of things you guys have coming up. Make sure that you're getting to the due dates because otherwise it becomes a long list of things that you don't get done. Why did it take me here? My agenda didn't work. Let me try again. I click on the wrong thing. Agenda. Oh, that's because I'm clicking on the wrong link. How about that one? There we go. All right, so you have an exit ticket to take. This is actually exit ticket to the notes you should have watched yesterday. Actually, I said them out loud to you, but I recorded our lesson and it's now posted for everyone else to. I actually said the notes out loud for the first 2 periods and I realized nobody's actually participating in the conversation, so I decided to record it and now it's on there for you to watch on your own, which will be the case for all lecture notes from now on until I see people participating a little better, because nobody answers my questions. Not nobody, I shouldn't say nobody, that's a generalization, but I would say 95% of you do not communicate with me when I ask a question. And I don't know why that is. And I have a survey ready to give you tomorrow that, why? I mean, tell me what it is. Is it because you're nervous? Is it because you'd rather chat with me like in the text box or through an email or whatever? I just need to know, because if it's not working for me to ask questions, I'll stop asking them. Not that that's a good thing to get you in the habit of, but I know this is a tricky situation and not everybody's comfortable. So I get it. Okay, so anyway, you have your exit ticket to do here for the lecture notes you watched yesterday or heard yesterday. This is just a simulation to go through and kind of get your idea of what we talked about yesterday. Here is a picture of base pairing, which is what you're going to practice today. Remember, this is a nucleotide, the phosphate, the sugar, the base pair. It's going to match up to its complementary pair, which means they go together, which is T and A, and then here's G and C. This is a strand, and this is a strand. The double helix, you're going to see the 5' end and the 3' end, and then going the opposite direction. That's called anti-parallel. You have a hydrogen bond connecting the two between. That's an easy bond to break, but because of that bond, that's why you have that spiral, that double helix. And then you also have a covalent bond holding the phosphorus and the sugar together. This is what it looks like when it's done. Those hydrogen bonds are what they're causing that double helix to turn. The phosphate and the sugar held together by a covalent bond. Here's another look at what you're doing. So when I say base pairs, you're looking at how these two come together. They're paired up and kind of zip up and stick together because of that hydrogen bond. So when we go to make a copy of it, it's going to break those bonds, those hydrogen bonds, to make a copy of itself. We'll see that later. But I'm just giving you a couple pictures to see how these two go together. Last thing you're going to do here is you're going to do a base pair worksheet. We're going to go ahead and click on that because I'm going to show you how to do that. You're going to click on this. It'll take you to the worksheet. But I did go ahead and give you a hint here. You're going to see the due date is the 9th. I'm giving you plenty of time. It's going to be open until the 12th if you're late getting things turned in. Let me go ahead and show you the sheet. I have one right here on my desktop. Let me make sure I'm sharing. And I left my pen way over there. Let me go get it. I obviously picked the wrong one. There we go. Now you should be able to see it. All right. So here's the worksheet that you're going to do. I'm just going to enlarge it just a little so we can see it a little better. And it has the same rules at the top as I talked about. When you're here, all you're going to do is make the matching pair. So what goes with C? What was its complementary pair? C and
G.
Anyone? G. G and C. T and A and T. A and T. G and C. C and G. G and C. C and G. T and A and T. A and T. T and A. T and A. And A and T. So this is the one strand. And I'm making its complementary, what it goes with. Complementary means goes with, just like you have French fries and you're having a complementary side of ketchup, if you like your fries with ketchup. Here's the other strand. And this strand here, 5' to 3', this would be the 3' to 5' because they're anti-parallel. Meaning it's going this way and it's going this way. They're going opposite ways on a street, right? In between here is your hydrogen bonds. That's how they're being bound together, those hydrogen bonds. These are your base pairs. Oops. You're making your base pairs. And this is important because this is going to lead us to the next parts we're going to learn, translation, transcription. So you do need to know how to do this because this is how you make the next set of information. Make sense? This is your DNA strand. You're determining what the code looks like. Remember, we talked about 3 of them being a codon, which means it's coding for a sentence to say something like purple hair. Or this is coding for one eyebrow. See anybody with just one eyebrow? Or you could pick a section and say codes for button nose. Okay. All right, the rest of this sheet's yours. I've helped you with the first one. You're going to do the rest of them on your own. And there are 12 of them, and I've given you a week to work on them. You turn it in by next Friday and it still be on time, but yes, I gave you a week to get it done. It should take you no more than 5 minutes if you know what you're doing. Any questions? Which question? Can I what? Were you watching when I was going through the lesson? No, so. Okay, if you're done, if you guys understand what you're doing, you're free to go. If you have any questions, please let me know. You have a few things to do on your own today. Make sure you get them done.